Okay, so start recording. Okay, so this is lecture number 2, and we are continuing from where we left off last time, which is histograms. If you look at slide 26, there's an example of a histogram about freshman graduation rates, FGR, standard histogram, and there are some questions that we might have. By the way, you should have the PDF now so that you can follow along. Hopefully it's working for everyone, so that I don't have to share the screen. So now we are interpreting a histogram, and let's look at the next slide, slide 27. It says examining a histogram. In any graph of data, you should be looking for the overall pattern and for any striking deviations from that pattern. So if you have a pattern that has a certain shape, but then a part of it just doesn't seem to go along with the rest of the shape, in such a way that you're like, whoa, what just happened there? That's a striking deviation from the pattern. So if I have a nice smooth curve that looks like this, let's say my data looks like this, but then has this, boop, and then it keeps going. It's like just that little blip just doesn't work with the rest of the data. It's what we would call a deviation from the data. You're looking for those. You're looking for things that stand out. But you want the overall pattern. We'll describe the 3 basic patterns that we're going to be dealing with in this class, and we're looking for deviations from that pattern. Now, in general, when you have that pattern, there are 3 things that you're looking for: shape, center, variability. Okay, the 3 features of a pattern that you're looking for are shape, center, and variability. And the shape is a conceptual shape. We're going to have words that we use to describe the shape, but the center and the variability will be numbers. So we're going to assign numbers to them. So for now, we're not going to worry about it. We'll wait till the next chapter. Just be aware that the 3 things we're looking for is shape, center, and variability. Sometimes you'll see variability referred to as spread. So the center is essentially the middle of the data, if such a thing exists. And the variability or the spread is how spread out the data is. Okay, is it from 10 to 100? Is it from 13 to 15? But even if it's from 10 to 100, there's different ways that it can be spread out. Is the majority on the wings, or is the majority in the middle? These are things that we'll talk about. And if you have a deviation, we usually call that an outlier. So something that's so different than the rest of the data that it's a striking deviation, we would call it an outlier. We will go into more detail all of these ideas. For now, we're just mentioning them in passing as things that we're going to be looking for. So let's start with the first one, which is the shape. The next slide. So there's 3 basic shapes that we're going to be working with in this class: symmetric, left skewed, and right skewed. Essentially, a symmetric graph is one that's it's like a mirror image, the left side and the right side. If you split the graph right in the center, you can almost fold the graph on top of itself. Doesn't got to be perfect, but something near perfect would be wonderful for it to be symmetric. If you look at the other 2 pictures there on this slide, the middle picture has the nice hump. It's pretty symmetric, but then on the right side, it has this tail, correct? It's up, and then there's a tail on the right side. We will call that a right skewed distribution. Okay, the tail is where the skewness comes in. So not where the majority is. The majority is on the left in the middle picture. But the skewness, what deviates from being symmetric, is the right side. We call that a right skew distribution. And of course, the last picture, the skewness is on the left side. We call that a left skewed distribution. Does that make sense so far? Yes? So let's look at the next slide. And again, let's not go too far so we see the answer, but rather let us just go enough that we see the question. Look at the following histogram of salaries of baseball players. What shape would you say the data take? A, bimodal, B, left skewed, C, right skewed, D, symmetric, and E, uniform. Now, we haven't talked about what it means to be bimodal. In fact, we haven't even talked about what it means to be modal or unimodal. What is a bimodal distribution going to look like?
Where there's two peaks.
Yeah, so essentially, not exactly, but essentially,
With two max.
yeah, so a bimodal distribution has two locations that are higher than everywhere else, and those two locations are essentially equal. I have one on the board behind me. Hopefully you can see it. Can you see this thing over there? So that's a bimodal distribution. It's got two peaks, and those peaks are essentially the same height. We call it a bimodal distribution. The next one, left skewed, means the tail's on the left. The next one, right skewed, means the tail's on the right. The next one, symmetric, means it's roughly a mirror image. And then uniform means essentially it's the same height everywhere. So given those 5 options, the question is, this graph, this histogram of salaries, what do you think it is? A, B, C, D, or E? So what we're going to do is we're going to all, does someone know which number we are on? Yes, we are on slide number 29. Right? Slide number 29. So what I want everyone to do is just, when I say go, I just want to type your answer in the chat box. A, B, C, D, or E. We're going to get a nice spam of answers, and we're just going to see whether or not the majority of the class understands or everyone's all over the place. So A, B, C, D, or E, 5, 4, 3, 2, 1, go. Boom, we got spam. So I see mostly C's, I see a B, I see a few B's, but I see mostly C's, and that's it. So let's take a look. Remember, the skewness is the tail. So there's a hump on the left, and the tail is on the right of the distribution. So C is correct. This is a right skewed distribution. Does that make sense? Questions? All right, so let's go now a couple slides down. Again, let's not look at the answer. So it says, look at the following histogram of percent urban population in 50 states. What shape would you say the data take? A, bimodal, B, left skewed, C, right skewed, D, symmetric, or E, uniform. I'll give you 5 seconds. 5, 4, 3, 2, 1, go. So I see lots of B's, I see a few C's, I don't think I see anything else. Uniform, certainly not the same height everywhere, obvious. Symmetric, certainly not, it's not a mirror image across the middle. Right skewed, certainly not. If there's a tail, the tail is certainly on the left. However, both A and B are acceptable answers here, because yes, there's a tail on the left, it is left skewed, but at the same time, there seems to be 2 peaks of approximately equal size, so it's also bimodal. Their answer is just left skewed, and I can understand why, because that's basically the, the gist of this section. But nevertheless, the answer truly is both left skewed and bimodal. You'd get credit for both. It's not the same, it's true, but they're approximately the same. You're right, they're not exactly the same, but they are approximately the same. And remember, because this is a histogram, we're dealing with classes, not specific values. So there's a little bit of wiggle room when it comes to how many there are, because if I change the class size, I can change, what the histogram looks like, and I can change the heights, etc. So it only has to be an approximation. Next one, again, wine bottles at a small winery are sampled and tested for quality. One measurement is volume. The bottles should be 750 milliliters. Of course, it's never going to be exactly 750 milliliters to the infinite decimal point. That doesn't make any sense. Is it possible you're able to share your screen? Do you not have access to the PDF that I posted on Canvas? I did post it, right? I posted it, correct? Yeah. Do you have access or no? Will you be putting these recordings on Canvas? Yes, I will be putting these recordings on Canvas. I do what it makes easier to keep up the pace. I'll try to slow down a little bit, but I would rather be able to, it's hard for me to see the chat, which is very important, and to see people's facial reactions, which is very important, so I can see if people are getting it or not, those who are on video, and at the same time share the screen. So I hope you understand from my point of view that it's easier for me for this. Now, I want to make sure people are learning the best way that's possible for them. Nothing is on my Canvas. Did you check the files in this course? And meanwhile, while you're checking, I'm just going to check to see whether I still have any emails from people who are trying to get in. Vanessa, you sent me what is a passcode, but apparently you found it because you're in. Hello. Vanessa, is this course on your on Canvas yet?
No, it isn't. It's not on Canvas.
Because
like
you didn't.
Not
Okay, and Tanya, welcome. Okay, so I will share again. Okay, so I will share again today, because I know people who came late. It takes a while for Canvas to update it, so I will share again. But and next week I would prefer not to, if that's okay. But however, no, it's okay. It's not your fault, because it takes a week. It takes a day for Canvas to update, so that's not on your end at all. However, I did see a way to see chats, so I can still see the answers to everything, which is nice. So is this okay right now? Everyone can see the PowerPoint, and I can see the chat, and I can see a few people. Is that okay? I hope so. I learned a new word today. I hope this is POG. Is that did I say that right? POG? I don't know. Someone in my last class used it. I don't know what it means, but anyways.
All right. It means player of the game. It means player of the game.
Play of the game.
Yeah, play of the game or player, either one.
Well, what does the O stand for?
Of.
Player of game.
Player of the game.
Gotcha. I still don't know what that means, but okay, I'm going with it. All right, so 6 new messages. It's Poggers, bro. Sorry, Poggers. And we good. That's right, I forgot that one. We good. Okay. Anyway, wine bottles at a small winery are tested and sampled for quality, and one measurement is volume. Okay. Why is it important to have the right volume? Well, the winery doesn't want to give too much, because then they're not making as much. They're losing wine by giving too much wine away for free, and they don't want to give too little, because if they advertise it at $7.50 and it's really less than $7.50, then they can be sued by the some consumer organization that makes sure that people aren't being cheated of their products. I'm paying for this amount. I want this amount. So it's very important to be near $7.50. So they sampled 50 wine bottles, and this is the histogram that they got. So it looks like 2 of them were between 744 and 746, and it looks like 7 of them were between 746 and 748, and so on. So the question is, based on this histogram, does 750 milliliters seem to be a reasonable center for the data? Center is basically the middle. So does 750 seem to be a good center? A, yes, the center is approximately 750. B, the center is too variable, so no. Or C, the data ranges from 744 to 755, so no. A, B, or C. So we're going to spam it in a second, or 5 seconds. 5, 4, 3, 2, 1. Wow, people are jumping the gun there a little bit. Oh, and now everyone's going. Okay. So I get a lot of A's. I'm going to make this a little tall. Can I make this bigger? Yeah. Okay. So after Lamal, we have A's, 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 A's. We got a B. We have A's. So mostly A's. Yes, the center is approximately 750, which is correct. You know, it looks pretty symmetric on both sides. Not exactly symmetric, but pretty symmetric. The center is too variable. No, the center is not too variable. The spread might be pretty variable from 744 to 755, but the center really does look to be somewhere near the middle, right? It seems pretty symmetric. So the answer is, in fact, A, which would be the next slide. Now, considering this histogram, About how many bottles of wine have more than 752 milliliters? A, 17, B, 44, C, 6, D, 5. And what I'm going to do is I'm going to type go when I'm ready to go in the box. So that way I'll know where each question ends. And once you see go, then you'll know that you're allowed to answer. So 5, 4, 3, 2, 1, go. Oh, I said go to someone privately. That was an accident. How do I fix that? Everyone in meeting. Okay, I apologize for that one. So let's go back to my go privately. We have 6. 6 is not an answer, but C is an answer. I hope that's what you meant. D, A, C, A, C, A, 17. Again, the answer would be A, not 17. A's, lots of C's. This one says C's a lot. Okay, so the answer is 6, because more than 752 means it's going to be the last 2 columns. That's 752 to 754 and 754 to 756. What's the count for this one? 5. What's the count for this one? 1. So what's the total count more than 752? Would be 6. Does that make sense? I'm not sure those who did not say C, what you were thinking for A, B, or D. So if you want to explain it, that would be great. I'm trying to see why someone would say 17, and I looked wrong. My bad. Okay, so we good now? We were bad before, but are we good now? We good. Okay. So the answer is 6. Okay, so let's keep going. So which 3 features can best describe the overall pattern of a histogram? Shape, center, and skewness, center, spread, and outliers, center, mean, and symmetry, or shape, center, and spread. I'm going to type go here, and when I hit enter, you're good to go. 5, 4, 3, 2, 1. Go for it. So I see an A, I see a bunch of D's, I see a few A's, I see a lot of D's from this one person. So the answer is D, shape, center, and spread. That is correct, because if we look back at here, right here, the overall pattern by its shape, center, and variability is referred to as spread. So shape, center, and spread. The other things are, of course, important, but the 3 main are shape, center, and spread. Skewness is just a type of shape. Symmetry is just a type of shape. Mean is a type of center. And outliers are important, that's true, but not as important as shape, center, and spread. So that would be answer would be D. And then they do it again for some reason. Next one, an individual value that falls outside the overall pattern is called A, the center, B, a shape, C, an outlier, or D, spread. I'm going to say go in 5, 4, 3, 2, 1. So that seems to be, everyone seems to be pretty in agreement on that one, and the answer is in fact C, no explanation necessary. So that takes us to the end of histograms. Are there any questions before we go on about histograms and what they look like and how to interpret them and the important features of them, etc.? Are there any questions? Sorry? Someone has their mic on, but I don't know if you're trying to ask a question or not. So we'll assume no. Okay, so let's move on now to the other method of displaying quantitative variables, not categorical. We had 2 for categorical, now we're going to have 2 for quantitative. And the second one is called a stem plot or a stem and leaf plot. And to be honest, I tried explaining this to my last class and it was very confusing. But when we actually looked at the example, everything made sense. So let's just go to the example. Essentially what you have is as follows. We have these 3 columns of data here. We have 192, 152, 135, all the way through 106. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 30 pieces of data for weight data for an introductory stats class. So suppose I took a poll, what's everyone's weight? And suppose everyone was honest and gave me their weights, and this is what they gave me. I can make a histogram out of this. That's true. I would define classes, maybe of width 5 or 10, whatever it is. And then I would put the count in each class. That's one way of doing it. Nothing wrong with that whatsoever. What we're going to do here is a stem and leaf plot. And what we do is as follows. The first thing we recognize is that all of these numbers end in the units place. What I mean by that is, the units, the tens, the hundreds, the thousands, the 10,000s, or the tenths, hundredths, thousands, etc. They all end in the units place. Do we agree with that? Every one of them ends in the units place. So what we do is as follows. We take the numbers to the left of the last number. So the last number is the units number. So we take the 2 that are on the left, or however many there are on the left of that, and we make stems. What we do, if you look at the blue box, you'll see that the smallest number on the top left of the blue box is 10, 10, correct? And if you go all the way to the bottom, the biggest number is 26. What those numbers represent, when you look at the data, are the first 2 digits, the smallest first 2 digits and the biggest first 2 digits. So the first data point, what are the first 2 digits of the first data point? The top left data point, what are the 2 digits? Anyone? Anyone?
19.
19. So the next one, what are the first 2 digits?
15.
15, 13, 11, 12, 18, and so on. So when you look at all 30 data points, what are the smallest first 2 digits?
You mean on this side? On the left side?
On the 3 columns of data on the left side, what are the smallest of the first 2 digits? For all of those 3 columns, 10. It occurs in the bottom of the middle column, right? And what is the biggest of the first 2 digits for all 30 data points?
26.
26. So what we do in the big blue box, you'll see on the left side, we do numbers from 10 through 26, correct? Those 10 through 26 represent the smallest to the largest, and we don't skip any. Even if nothing in the actual data starts with 16 or 17 or 18, makes no difference. Smallest to the largest, we don't skip. Now, if you look at this thing, after the first 2 digits, we draw this big vertical line all the way from top all the way to bottom. And then after the 19, we write a 2. Why would I write a 2 after the 19? Where does that 2 come from? What does it represent?
From 192.
From 192. Okay, from 192, we have 19 as the stem, and then 2 is the leaf. And then for 152, we have 15 as the stem, and 2 as the leaf. And then 135, 13 as the stem, and then 5 as the leaf, and so on. So the next number would be what? After 135, what would I put down next if I was filling out my stem and leaf plot and I was going in order, let's say?
0 next to 11.
A 0 next to 11. And then?
An 8 next to 12.
An 8 next to 12. And then?
0 next to 18.
And so on. So what happens when I get to the very bottom of the first column and I get to 150? What do I do now? All right, the last data entry in the first column is 150, correct? So what do I write in my stem and leaf plot once I reach 150? What do I do with that number?
You put a 0 next to the 2?
I put a 0, well, almost.
Oh.
Almost.
The 0 in front of the 2?
Yes, you put a 0 in front of the 2 because you want them to be in numerical order. Right? So 15 as a stem has at least 2 leaves. One leaf would be a 0, and one leaf would be a 2. And if I quickly look through the rest of the data, is there any other leaf for 15?
I don't think so.
I don't see any on a first glance. I don't see any. So the stem for 15 would have 2 leaves, a 0 and a 2. So I would see 1, 5, line, 0, 2. And I know that the 0 and the 2 both hit the 15. So 1, 5, 0, and then 1, 5, 2. I don't write 1, 5 over and over and over again. I just know by the way these things work that the 1, 5 hits everything after it. Does that make sense? We'll see an example in a minute. Sometimes you might see 2 lines of 15, 2 lines of 16, 2 lines of 17. And that's when we feel that it might be better described to split up the 1, 5 stems into 2 possible leaves, 0 to 4 on one line, 5 to 9 on the next. 1, 6, 0 to 4, 1, 6, 5 to 9. 1, 7, 0 to 4, 1, 7, 5 to 9. Okay, and that usually occurs if you don't have a lot of stems, right? If you don't have a lot of stems, then you don't want to have these long, 3 long lines, but you double it and you make 6. Let's look at a quick question. Okay, in the data set represented by the following stem plot, in which the leaf unit is 1.0. So this is very important. The leaf unit is 1.0. So tell me, when you look at this data, what is the smallest number that occurs?
0.9.
0.9. What is the next smallest number that occurs?
1.2.
1.2, and then?
1.4, 1.6, and so on.
And then 1.9, 1.9, 1.9. Actually, I misread the question. I apologize. The leaf unit, see all those dots that are in the vertical line? So I thought those dots meant for them to be decimals, 1.2, 1.3, and so on. They're not. Those dots shouldn't be there. It's a mistake. It's a mistake. The leaf unit is 1, which means the first number is straight up 9, not 0.9, but 9. And the second number is 12. So my apologies for that. I saw those dots and I thought they were decimals, but they're not. That's a mistake. It's 9, it's 12, it's 14, it's 16, 19, 19, 19, and so on. So the question is, how many times does the number 28 occur? Right? A, B, C, or D. The number 12, someone's already answering. Oh no, I didn't say go. Oh, sorry. It's okay. I forgive you. I'm not sure I'll ever forgive you again, but I'll forgive you this. Oh, people are still going. No, let's go now. Wait for me to say go. Otherwise, you're robbing people the opportunity of not being influenced by their answers. So amazing, everyone says through C28 and the answer is 28, so that's great. So let's move on. So what is one advantage of histograms over stem plots? Again, don't go until I say or type go, but what is one advantage of histograms over stem plots? A, histograms can be done by hand. B, the data set can be any size. C, the actual data can be extracted from the histograms. Or D, histograms can be horizontal or vertical. So 5, 4, 3, 2. Oh, someone jumped the gun again. Incredible. No matter what I do, everyone jumps the gun. Oh, no. So everyone's saying B. I think everyone said B. Did anyone not say B? I think everyone said B. Wonderful, right? Histograms can be created by hand. Well, so can stem plots, right? It's not hard to make a stem plot by hand, so that can't be it. Histograms can be horizontal or vertical. Yeah, just turn it sideways. That's not a problem. Can the actual data be extracted from histograms? Well, no, because you have a class, 60 to 65, but you don't know where in the class it is. But the data set can be any size. That's not a problem. So the answer is, in fact, B. Now, what's an advantage of stem plots over histograms? Why would I want to do it in the other direction? Why would I want to pick a stem plot? A, stem plots can use classes of any size. B, the data set can be any size. C, the actual data can be extracted from the stem plots, or D, stem plots can be horizontal or vertical. I'm going to type go, and I'm going to go 1, 2, or sorry, backwards, 5, 4, 3, 2, 1, go. So we have C's across the board, and that is correct because you know exactly what the data is for a stem plot, something that's missing for a histogram, so that is correct. So now we talk about the third type of object. There's categorical variables, there's quantitative variables, and then there's a special type called a time plot, which is really neither of the first two. A time plot shows the value of one quantity over time. So we keep looking at the same quantity over and over and over again, every month, every week, every year, every decade, every day, every second, right? You ever see these doctor TV shows where people are on these machines, you know, the beeping machines, what are those called? You know, the boop, boop, you know what I'm talking about? What are they, come on, someone's got to be a pre-med here. EKG, what does that stand for? Electro something graph, electrogram. Well, it's a heart thing. Cardio, electrocardio. There we go. Electrocardiography. Wow, that's a big word. Damn. Electrocardiography. 8 syllables. World record. Awesome. So an electrocardiogram is this time plot. It gives me the heart rhythm, the heartbeat, the heart pulse, the heart something, successively over time. I don't do you and me together. It's the same thing studied successively. So a time plot shows behavior over time. Time is always on the horizontal axis. And whatever you're measuring is on the vertical axis. There's no exceptions to that. That's just the way it is. Time is on the horizontal axis, and the variable being measured is on the vertical axis. What are we doing? We are looking for an overall pattern, what we call a trend. We're looking for deviations from the trend. And usually we connect the data points by lines so that we can emphasize the trends. And we're looking for patterns that repeat. If you're into the stock market, maybe you'll see, hey, every winter this goes up and every summer this goes down. You have this seasonal variation that you might want to take advantage of. So here's an example of a time plot. It shows the class makeup on first day, what % are freshmen. Notice the horizontal axis is time, it's the year. And the vertical axis is what we're measuring. What is the general trend for this time plot? How would you describe the general trend for this time plot?
Positive?
I'm sorry?
Positive?
I don't think we would use the word positive, but upward. It's an upward trending. I mean, I understand why you would say positive because it's a positive slope, but usually we would say upward trend. And slowly, increasing slowly, okay? Notice that it doesn't always increase, right? It dropped one time. What happened in 1989? I don't know. Maybe I might want to look into that and see what occurred in 1989 for such a radical drop. In 1991, it dropped a little bit. Why? In 93, it dropped again. Why? In 1986? These are things that you might want to ask yourself. I see an overall trend, and then I see deviations from that trend. Why are those there? As a statistician, that's something you may or may not be interested in. Here's one. The average tuition and rates for public and private universities as a function of the academic year from 1970 to 2000. What do you notice about average tuition in public schools between 1970 and 2000?
It's uniform.
It's pretty uniform. It really hasn't gone up much. I mean, it has gone up, but so has inflation. So perhaps it's actually gone down. I don't even know. Right? Money back then was worth less than money now, or more, or something. I don't know. $100 now doesn't go as far as $100 back then, right? You see these old movies where someone buys a hamburger for 5 cents or something like that. Can you imagine living in that world? I'd be fatter than I am now. That would be amazing, okay? So it's pretty uniform. But what about private schools? Scam?
Love skewed.
What's a scam? Oh, private schools are a scam? Damn, girl, that's kind of a jaded attitude. You might be right, but I don't know. So scam is increasing. It was 800. Doesn't give me the units, so let's assume it's dollars. $800 for average tuition in 1970, and now it's up to roughly $18,000. So that's a pretty steep increase. It actually was pretty uniform from 70 to 80, and it was only in 1980 that things started going up. So as a historian, I might wonder, what happened in 1980? Was new regulation passed? Were there new laws in place? Did something occur? I don't know. These are things that people might be interested in. Not me personally, but other people. So here's a question. Which of these is a time plot? Just plot A, just plot B, both of them, or neither of them? Cough, cough, Reagan. I don't know enough about politics to know whether or not you're correct, Dominic. I don't even pretend to know what effect the president has on economics. That's not my field in any way, shape, or form. So I don't know if you're right or not. You could be wrong. I can't comment on it. I do know that something must have occurred in 80, and Reagan did become president in 80, so maybe that has something to do with it. I can't talk about that. It's a joke, but Carter versus, no, it might not be a joke. I mean, listen, especially in this climate that we're in, not necessarily the pandemic, but the political climate that we're in, people have very strong opinions about the effects that politicians have on the world, on America, etc. All I can say is I know nothing about politics. It's just not something that I have any expertise in. So I might also make jokes about it now and again, but the truth of the matter is that I don't know. It could have been. My dad's in the next room, and he's much smarter than I am about those kind of things, and always trying to talk to me, and I tune out. I just want to do math, So anyways, back to the math. Which of these plots is the time plot? A, B, both, or neither? I'm going to do go, and I'm going to do 5, 4, 3, 2, 1, go. All right, so I see lots of A's. I do see a C. I don't think I saw a B anywhere, but I did see a C. And you got to be careful here. Remember, the very first condition of a time plot, the horizontal axis must be time. Time must be on the horizontal axis. And if I look at this one, this is year. Well, that's years of time, but net generation of electricity, that is not time. That's measuring something else. I don't know what it's measuring, but it's certainly not time. So the answer is just A. Plot A is the only one. Okay, with me so far? The following, what type of trend is this? Is it upward, is it downward, or is it no trend at all? A, B, or C. I actually read them out of order. Downward, upward, or no trend. So I'm going to say go 5, 4, 3. Oh my God, someone jumped the gun again. Oh no, everyone jumps the gun. You guys are killing me. Someone starts. You're like the guy who fires that first shot, and everyone's like, don't fire. But once one guy fires, everyone fires. That's what it's like. And the answer is, in fact, B. It is upward. So that was pretty strong. How about this one? Would you say there's an upward trend, a downward trend, or would you say it just shows straight up killing me smalls? Anyone who quotes The Sandlot is A-okay in my book. So the upward trend, the downward trend, or there's seasonal variation, 5, 4, 3, 2, 1, go. And this one, hopefully everyone says C. It's pretty straightforward. It doesn't go up, doesn't go down. It just keeps going back and forth. Okay. And the last one of this packet, and then we'll take a break, and then we'll go into chapter 2. For data involving answers to the following question, what is the best method of displaying the data? So the question is, how many times have you accessed the internet this week? Never, once or twice, 3 or 4 times, or more than 4 times. We take a poll, we get our responses, and we want to graph them. So do we do A, a bar graph, B, a box plot, C, a histogram, or do we do A, scatter plots? So I'm going to give you a couple seconds to think about it. And I'm going to do go, 5, 4, 3, 2, 1, go. So I see lots of A's. I saw C. I saw a couple C's, a few C's. Okay, well, first, we haven't even mentioned what a scatter plot is, and we haven't mentioned what a box plot is. So hopefully you don't say B or D, because we haven't even used those terms yet. And they're not going to throw you a question whose answer is something that we haven't described. So you can immediately eliminate those possibilities, right? But what we have here now is two possibilities, either a bar graph or a histogram. And these two we have talked about. A bar graph is for categorical data, and a histogram is for quantitative data. So one of the categories, well, I already threw it out. I said the word categories. Yes, I will as well. As soon as we take our break, I'm going to go find the PowerPoint too and throw it up there. But never, right? Never is a category. They're all four categories. How do you average the word never with numbers? These numbers are not numerical numbers in the sense that we do math. They are categories. It says categorical data. Categorical data uses a bar graph, so the answer is in fact A. Fantastic. And we are done with PowerPoint number 1 and chapter 1. I'm going to stop sharing for a minute. Are there any questions before we go on? We're going to take a 5-minute break, but are there any questions on the first chapter? Great. It's always nice to know. Quantitative uses, yes, correct. Quantitative definitely uses histogram. Histograms are for quantitative as well as stem plots. And bar graphs and pie charts are for categorical. And never the twain shall meet. That's not Mark Twain, but rather the two of them. Because Mark Twain's dead, so he can't meet anyone, I think. Anywho. So it is now 7:24 on my computer, so we will meet back here at 7:30. I'll give you a 6-minute break because I'm that generous. We'll come back at 7:30 and we will start PowerPoint number 2, which I'm going to now look for and post. So take a few minutes and I will see you all soon. Oy. how do I do this? Okay, I found PowerPoint 2. So we're going to post it in intro files, chapter 2. Okay. Okay, chapter 2 should be up. Let's confirm that it is, if that's okay.
Yeah, I see it.
Wonderful. Sorry about that. No problem. Okay, you're good. It happens. Wonderful. Okay, so is everyone back? Can I get a quick here from everyone so that I know that you're back?
For the file you uploaded, what file type is .key?
Oh, yeah, it's. I don't know if it's the right file.
Yeah, it's not a PDF.
Okay, hold on. Let me export it as a PDF, and I'll do that again. Hold on.
If you're on Safari, sometimes uploading or downloading documents makes like it does that.
No problem. No problem. Give me a second. I will delete this, and instead, I will upload this, which is a PDF. Okay, it's there, and that should be good to go. Is that better?
Yeah, it's good
Yes.
now.
Okay. All right, excellent. So let's continue. I'm going to share my screen again. And hopefully everyone can see this. Throw in the chat. I'm gonna make this a little smaller. How do I do that? I guess I can do it here. Okay. So there's the chat. And okay, are we all ready? Okay, that's a resounding yes. You're complete and under silence. Has me a little worried, but okay. Okay. So we good. Okay, that's good. We good. Okay, so chapter 2 in our textbook, describing distributions with numbers. Wonderful. So in this chapter, let's see what we're going to cover. We'll survive. Okay. In this chapter, let's see what we're going to cover. The first thing we're going to cover is a measure of the center. We talked about last section, the center, but we didn't really specify how to calculate a center. We're going to come up with two different types of centers called the mean and the median, and we're going to compare them. There are times that you'd want to use the mean, and there are times that you would want to use the median. They are technically different, and they're used in different ways and at different times. So we are certainly going to talk about that. We also have the second of our three things, remember, was shape, center, and spread, right? Or shape, center, and variability. When it comes to variability, we're going to measure it with things called the quartiles, which you may or may not have seen before. And then once we have these quartiles, we're going to construct what's called the 5-number summary and a box plot. Now, the box plot is something that I just mentioned as one of the possible answers for one of the previous questions was box plots. So we're going to see exactly what that is. Now, when you make a box plot, we also have the possibility of seeing outliers. So we're going to come up with a mathematical way of determining whether or not something is an outlier. And if it is an outlier, we're going to create what's called a modified box plot to take that into account. Then we're going to have a second way of measuring variability called the standard deviation. And again, we're going to talk about when you use which. Which time do you want to use this measure of center? And this time, where do you want to use this measure of center or variability? And then it says examples of technology. We'll see what that means when we get to it. So, measure of the center. So the last chapter had no math in it. And the math starts now. The most common measure of center is what is normally referred to as the average. It's more appropriately referred to as the mean, or technically the arithmetic mean, because there is a different type of mean called the geometric mean, which we're not going to worry about. But the first measure of center is called the mean. How do I find the mean? So first, we want to have a way of labeling the mean. We use the notation x bar. That's x with a bar on top to represent the mean of a set of observations. What we do is we add their values, and then we divide by the number of observations. So if the n observations are labeled x sub 1, first x, x sub 2, the second x, x sub 3, all the way through x sub n, the nth x, then their mean is labeled as x bar. What do? x1 plus x2 plus x3 plus x4 plus all the way through xn. And then we divide by n, and that gives us x bar. This is something that you've seen before. I remember even as a kid, you take a few tests, you want to know what your average is. What do? You add them up and divide by how many tests you took, right? We should be familiar with this. Is there anyone who's not familiar with this? With this average, this x bar that that you've used before, hopefully. At the bottom of this spreadsheet is, PowerPoint, is this a notation for x bar with this Greek letter capital sigma. Is there anyone here who does not know what that capital sigma means?
I forgot what it means.
Okay.
Yeah.
Yeah, so what the capital sigma is essentially standing for is adding. When you see that capital sigma in this context, it's telling you to add. What are you adding? You're adding the x sub i's. In other words, you're taking the x sub 1, the x sub 2, the x sub 3, the x sub 4, the x sub 5, etc., and you are adding them. That's all it's telling you to do. And then you put it over n because that's part of the formula, over n, or times 1 over n is the same thing. Does that make sense? It's just a compact way of describing the same formula without that dot, dot, dot in the middle, which from a mathematical standpoint is never the best way to go, because dot, dot, dot can oftentimes leave out some information. Okay, so you add up all the x's, the observations, you divide by n. Any question? Where does the 1 over n come from? That's this part, right? The 1 over n is the same thing as the over n in the beginning. You add them up and divide by n. You add them up and multiply by 1 over n. That's essentially the same thing. Dividing by 2 and multiplying by 1/2 is the same thing. Dividing by 10 and multiplying by 1/10 is the same thing. Did that answer your question? Sydney, did that answer your question? We good. Okay, we good. Okay, so question. Find the mean of the following 9 numbers. So this is certainly a, well, actually, you know what? I'm not even going to use my calculator. I'm going to do it in my head. You guys go, and I'm going to go and see who gets there first. Okay, I lied. I can't do it in my head. I tried. I had an idea. It didn't work. Okay, this one I'm going to give a couple more seconds before we do it. Okay, so that's enough time. So 5, 4, 3, 2, 1, go. Oh, I did a private thing again. I don't know how that happens. So I have lots and lots of D's. In fact, I have an A, but I have a lot. I have 6D. I don't know what that means, 6D. Is you multiplying D by 6? I don't know what that means, but mostly D. So the answer, oh, I see why you might have said A, because 64.6 rounds to 65. That's true. But, you know, if you have 64.6 as an option, you go with it, right? If it wasn't there, I would say 65 is correct, but the correct answer is in fact D. Does that make sense? Yeah? Okay. Next one, the median. So the median is an alternative way of measuring center, and it is done in a completely different way. In fact, you can't really, well, you can't really use a calculator for this. This one you got to write out, okay? What you do is you take all of your observations, like the 9 observations we have here. In fact, I'll use this as an example. And the first thing you do is you put the observations in order from lowest to highest. Now, whoever made the spreadsheet was very, very nice, because what do you notice? They already did that for us. 43, 54, 55, 63, 67, 68, 69, 77, 77, 85. It's already in order, right? How sweet is that? Do we agree? Yes? No? Maybe so? Everyone? Anyone? Yes. Oh, capital yes. Really enthusiastic. So the first thing you do is you put the numbers in numerical order from lowest to highest. So they already are. Then you do nothing more than you take the middle number. Now, in our case, there's 9 numbers, correct? So when there's 9 numbers, finding the middle number is really, really easy. Which of those 9 numbers is the one in the middle?
67.
67. It's the 5th number. There's 4 numbers. There's 4 numbers, and then the one right in the middle is number 5, right? So when there's an odd number of numbers, finding the median is easy. It's just the one in the middle. But what if there's an even number of numbers? What do we do then?
Take the two medium numbers and thing, add them up and divide it by 2.
Yes, exactly. You take the 2 numbers that are in the middle, and essentially you take their average. You add them up and divide by 2. Now, there's a nice little formula that you can use to calculate the median. Well, not to calculate the median, but to calculate the spot that the median is in, more specifically. What you do is you take the number of data points, you add 1, and then you divide by 2. How many data points is this data set that we're looking at right now?
9.
9. So you add 1, getting 10, and divide by 2, correct? So now you have 5. That doesn't mean the median is 5. We just said the median is 67. So what does that mean? You get 5 and there's your answer. What does that mean?
Does that mean the number is in the 5th position?
Exactly it. The median is the one in the 5th position. That's exactly it. So this formula does not give you the median, it gives you the spots of the median. Correct? Now, let's imagine that we had 10 numbers. And let's use the same formula. Add 1 and divide by 2. If there's 10 data points and you add 1, what do you get?
$11.
Divide by 2, what do you get?
5.5.
5.5. So it's in the 5.5 spot. What does that mean, the 5.5 spot? That means halfway between the 5th and the 6th spot, which again is what we got when we mentioned earlier, you just add them up and divide by 2. So take the number of data points, add 1, divide by 2, and that gives you the slot for your answer. Does that make sense? Are there any questions for that one? Yes? No? Okay. So to find the median of a distribution, number 1, arrange all observations from smallest to largest. If the number of observations is odd, the median M is the center observation in the ordered list. And if the number of observations is even, then we average the 2 of them. And you could always locate the median by adding 1 and then dividing by 2. Does that make sense? Any questions on that one? Kind of important. Yes? Okay, let's move on then. So question, I guess we already did this one. I kind of jumped the gun a little bit, my apologies. But find the median of the following 9 numbers. So I'm not even gonna ask of a, I'm not gonna do a poll here because I essentially just gave the answer. What are these things here? Did I do those? I don't know, whatever. So what is the answer to this one? 67, we've already answered that question. Let's move on. Okay, so. Before we go on to this one, I guess we should address the following question, which is when would I use the median and when would I use the mean? When would I use the median and when would I use the mean?
Mean is for average?
Well, they're both average. Well, the mean is the word that we would use for average. That's correct. But both of them are measuring center. So the question is, when would I want to use the mean to measure the center? And when would I want to use the median to measure the center? Why would I use one over the other?
Would you use mean? Well, obviously mean to calculate the average of the overall group. And then you would use median to find an individual in the middle of the data set?
No. Both of them are measures of center. And you would never really use both in the same problem. Some problems, the mean is the best way of getting the center. And sometimes the median is the best way of getting the center. And here's when you would use which. Let's go back to the previous example for a second. Suppose you have...
I was going to say that you should use probably median if there's a lot of outliers maybe.
Okay, so outliers...
If there's a lot of outliers, it might mess up the data as opposed to using mean.
Okay, that's excellent. Suppose you were looking at these 9 numbers, and instead of writing 85, you actually typed in you accidentally typed in 850. You made a mistake. You're typing, you're going fast, and you make it 850 instead of 85. How would that affect the mean?
By a lot.
It would really raise the mean, correct? Because now the average is a lot higher, right? Correct? How would that affect the median?
Not at all.
Not at all. The median will not change at all. It won't. That's correct. The median will not change at all. So median is good when you have outliers. When you have skewed data. The median is good when you have outliers or skewed data. The mean is good when you don't have outliers and it's symmetric. Or nearly symmetric. Again, doesn't got to be perfect, but it's got to be fairly close. Again, the mean is for symmetric data with no outliers. And the median is for situations when you do have outliers or it's not symmetric because it's either left skewed or right skewed. And here in this slide is a great term. I don't know why I can't scroll like I did before, but whatever. It says the mean cannot resist the influence of extreme observations. If you have a number that's way bigger or way smaller than the rest, the mean cannot resist its influence. The mean is going to change. It is not a resistant measure of center, or what we call it is not robust. Okay, those are pretty much synonymous. A resistant measure is one that resists outliers. Is the median a resistant measure? Yes. The median does a great job at resisting outliers. So the median is a resistant measure, but the mean is not. So we would use the median when there are outliers, or in general, it's skewed, because then you have numbers that are far to the right by the tail or far to the left by the tail. And you would use the mean if you don't. Does that make sense? Okay. We good. Excellent. So let's go down. We did this. We did this. Okay.
I also have a question.
Yes, go ahead.
Do you have, like, when we're doing homework or exams, do you have like a specific set, like how many decimal points we should round to? Like,
I mean,
because I've had different statistics teachers like over time tell me like different numbers they like each has to be rounded to, like overall in the whole class.
I'm not gonna be too particular about that. But if you write every single decimal in your calculator, yeah, I'm not gonna give credit for that one. I mean, use common sense. Usually two decimals or three significant figures is usually good. But if you have like 8 or 9 decimals and you use them all, that's not going to be great.
Okay, thank you.
Does that make sense? Did I answer it?
Yeah.
Okay. So sorry, can we do an example later to find a median when n is even? So yeah, we can do that. Why don't we do it for this one? Why don't you give me another number above 85? So 90. Okay, so what I want you to do on this slide is pretend, or even here, wait a second, I can annotate. So I thought I could, hello, look at me, I'm so cool. Draw. So suppose I have a 90 as a 10th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I throw in 90. The question is, what is the median? Well, now there's 10 numbers. So 1, 2, 3, 4, 5, break. 1, 2, 3, 4, 5. So it's halfway between 67 and 68. And what number is halfway between 67 and 68? What's the average of those two? 67.5. Does that make sense? Notice, by the way, 10 digits. So 10 plus 1 is 11. Divided by 2, 5.5. 1, 2, 3, 4, 5, 5.5 right here. 5.5. And then what does that mean, 5.5? It means the average of the two numbers on either side. Okay? Yes? We good. So let me clear and get rid of this. Okay. Okay. So suppose you have the following. You have 15 randomly selected North Carolina workers who were asked to calculate their commuting time. How long does it take to commute to work? There's 15 of them. And suppose you were asked to find both the mean and the median. So how do we find the mean? We add them all up and divide by how many we have, right? We add them all up and divide by 15. 30 plus 20 plus 10 plus 40 plus dot, 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 plus 10 plus 10 divided by 15. So I'm going to trust the math and not do it myself, something that I do not recommend for you. You should always test everything and check everything. But let's assume that they are correct and their answer was 22.5 minutes. How do we now find the median? Well, step one is we have to put them in order. What's the easiest way to put them in order? Well, personally, I think a stem and leaf plot is a great way of writing them down. So look at the stem and leaf plot. Notice that every one of those numbers ends in the unit place. Because every one of those numbers ends in the unit place, my leaf is going to be the units number, and my stem is going to be the numbers that come before it. In this case, there's only one number before it. The smallest number here is 5, correct? So 0, 5. The largest number is 60, so 6, 0. And we do every stem in between. So 0, 1, 2, 3, 4, 5, 6. Even though there is no leaf for 5, we still write it. Easy way to lose points is to skip because there's no data for 5, but I don't care. Like a histogram, we do not skip classes. So 0, 5, then there's 10, then there's 10. Then there's a big black arrow or purple arrow that's covering it, and I can't see what numbers are there, but I think it's another 10, and then 12 and 15 and so on. So if I want the median of 15 numbers, 15 plus 1 is what? And this is a tough one, but 15 plus 1 is what?
16.
16. Divide that by 2, a little tougher. What do we get?
8.
8, which means the median is in the 8th spot when listed smallest to largest. So 1, 2, 3, 4, 5, 6, 7, 8. The median is the left 20. Not the second 20, it's the left 20. You might say, who cares? 20 is 20. There's a reason for that. The median is the left 20. I'm sorry, 1, 2, 3, 4, 5. The left, yeah, I was right, the left 20. All right, 7 numbers to the left of that, 7 numbers to the right of that, and the one right in the middle is 20. Are there any questions? So question, I guess I'll ask a question. What is the best guess for the median number of milliliters for this sample of 50 wine bottles? This is the first question so far that might not be so obvious. I mean, listen, I'm not saying everything's obvious. People do get things wrong, but this one, I think you have to think for. What is the best guess for the median number, the middle number of milliliters for this sample of 50 wine bottles? A, 749, B, 752, C, 750, or D, 748. I'm gonna give you guys a couple seconds. I'm actually gonna do it myself quickly. Okay, I have my answer. Okay, so I'm gonna type in go. And if you don't know the answer, type in E. That way I have an idea. Don't just guess a random answer if you don't know. And maybe you're right, maybe you're wrong. But type in E. That will be the indication that you just don't know how to do this problem. Because if I see a lot of E's, I know to go over it. If I see 1 or 2 E's, then come to my office hours. So 5, 4, 3, 2, 1, go. Okay, so I do have some E's, which is great to see. People are not sure how to do it. I see a lot of C's. I see an A. Lots and lots of C's. And the A right here wins it. The A is correct. So let's see why. At least that's my answer. We'll see if I'm right. Let's see why. How many data points are there in this problem?
50.
50. And we know the median is the middle one of those 50, correct? Now, because 50 is an even number, it's halfway between which and which?
748 and 750.
Oh, wait, no. In terms of the 50 data points, 1 through 50, the median is halfway between which and which?
1 and 50.
Well, more than that. Be more specific. Which position is the median in?
25th place.
It's not the 20th place.
I said 25th.
Not the 25th place.
Hmm.
Remember, it's an even number, so it's not the 25th place.
25th and 26th.
It's halfway between the 25th and the 26th place. Correct? The median is halfway between the 25th and the 26th. So let's identify what is the 25th and what is the 26th. How many do we have in the first column?
2.
2. How many in the second column?
7.
For a total of how many?
9.
9. How many in the third column?
About 18.
About 18.
18. For a total of how many? 9 plus 18. A total of how many?
27.
27.
27. So that by the end of the third column, we have 27 data points. Correct? Which means the 25th and the 26th were in this class. Now, where in the class? I have no idea, so I'm going to assume the center of the class. So if the 25th and the 26th were both the center of the class, which is 749, then what's halfway between the 25th and the 26th? Also 749. And therefore, I say the answer is A, and the correct answer is C. Well, they're wrong, and I'm right, and that sucks for them. This is incorrect on their part. And I'm going to have to talk it to. Now, who just saw the answer and copied C because it said C? Be honest. Who here did that? Anyone?
I personally picked C because I looked at the bar and 750 was in the middle.
That's right. 750 is in the middle, and I would say 750 might be a good guess for the mean, although this one's a little higher than this, and this one's a little higher than this, and this one's a little higher than this. So I would even pick the mean to be slightly to the left of 750 and go with 749. But in this case, this answer is 100% wrong. The median is halfway between the 25th and the 26th data point. And because it's halfway between the 25th, you just identify what is the 25th data point and what is the 26th data point. And they are both 749, huh?
My bad, I have a question. So, I mean, I got 750, but what I did, I don't know if this is correct or not, but I added 748 and 752 and divided it by 2.
Why those two?
Just because they were because they were the highest ones. So I don't
No, they're not.
No, okay.
748 is the left side of this graph of this column. It's true, but I would use the middle data point for the column itself.
Okay.
Okay, so 749 or 751, but because both the 25th and the 26th are in this class, I would use the center of this class for my guess for the median, and that is 749. And I know who prepared these notes, so I will email him tonight and say, even though you have a PhD in statistics and I don't, you are wrong on this one. I'm not going to use those words, but But hopefully he will come back and he will say, you were right. And I just want to show you something. I want to show you something here, just to let you know that I know what I'm talking about a little bit. So there's a book on advanced calculus by James J. Callahan. It's a book right here. And this errata file is a listing of mistakes that were discovered by people out there in the world who emailed the author and said, hey, we found some mistakes and we would like you to correct them. And let's take a look at that file. Can someone please read the beginning of that file? That's right, this guy. Okay, I find mistakes because that's what I do. I find mistakes. These are all.
Did you do all of that?
These are
Wait,
all
that's all you?
These are all
Did
mine.
you just bully the author?
I didn't bully him. I emailed him and said I found mistakes. I also did that for this book here. This is the Geometry of Space-Time. I wasn't the only one, but here I am, David Berkowitz, right there. I've also been listed in the preface of the second edition for, thank you very much, guys. I appreciate that. I appreciate that. Thanks. I am when I read, I'm very particular. I'm looking for mistakes in the smallest little things, and I find them. Now, that being said, Pogger, that's right, this guy who has 2 thumbs and is a Pogger right here. But anyways, so.
But when's the book coming out? When's your personal book coming out?
Oh, I don't write my own books. I just find other people's mistakes. It's a lot easier that way. If I wrote a book, people would do that to me, and I can't handle that. But the point is this, is that I emailed him a bunch of stuff. It's true. And sometimes he would write back and say, no, the answer was this. And I'd be like, oh, okay, you're right. I didn't realize. So I'm not saying everything that I find is valid. But just so you know, I've done that before, and I will do it in the future, because that's the kind of guy that I am. So I'm going to talk to the guy who wrote the slide and say, listen, I really believe you're wrong. And listen, he might come back to me and he might say, well, actually, no, I'm right because of this, in which case I will come back to you and say, guys, I made a mistake. I'm very sorry. Here's the answer. But as the way I see it right now, the answer is 749. But someone did ask, I still don't get why it's 749, but I'll stay back after class. No, it's okay, because if you don't get it, other people don't get it as well. We're looking for a median, correct? The median is the middle number when written from smallest to largest. That is what the median is. Because there's 50 numbers here, and it's an even amount, the median is going to be halfway between the 25th entry and the 26th entry. Do you agree with that so far? So let's write out the numbers. It's 745. That's my first one. Horrible for it, but 745. Then I had another 745 because there's 2 of them, right? A height of 2. Do you agree? And then I had 747, which is the middle of the next class. And how many 747s did I have? I had 7 of them. Because what's the count of that class? The count of that class is 7. So there's 2 of these, and there's 7 of those. And then how many 749s do I have? How many 749s do I have? Well, what's the count of the 749 box? It looks like there's 18 of them, right? Sydney, you with me so far? Okay, so by the time I reach 749, I have 2 plus 7 plus 18. That's 27 data points, which means data point 10 through data point 27 are all 749. Because 2, 7 for a total of 9, and then the 10th, 11th, 12th to the 27th, these 18 data points are all 749. Which means the 25th is 749 and the 26th is 749, which means the average of them is also 749, and therefore the median is 749. Does that make sense? More sense? Less sense? Equal sense? Okay. Does anyone still have a question on why I personally believe the answer is 749? And my logic. It's not just the answer.
I'm having a little trouble with, like, how did you get 7 for 747? That's just,
look at the height of the box. What's the height of the box?
I assumed it was 8. I don't know why, but it looked like, I'm sorry, I'm kind of blind.
It's okay.
Yeah,
It's okay.
makes sense.
I mean, it's 5 to 10, right? So I don't know.
You're right.
It's definitely less than the halfway point. So it's not that much less. So I think it's 7. Okay. So does that make sense how I did that, everyone?
Well, I think what led a lot of people astray is the word guess, best guess. And what would lead us to the actual answer, which you plotted out, would be not guessing. It would be finding the exact place.
And you know what? Maybe that's what the author of these PowerPoints meant. Maybe that's what he meant.
That should be the correction you give him then.
Well, I will speak to him and I'll say, you know, if that's what you meant, then fine. And if the way I interpret is what you meant, then you should change something, the wording or change something. But either way, do people understand why I believe my answer is what it is? Where did the 10 to 27 come from? There's the first and the second data points are 745. The third, fourth, fifth, sixth, seventh, eighth, and ninth data points. These 7 data points, because it's a height of 7, are all 747. And then the 10th data point to the 27th data point, those 18, which is the height of the third column, those are going to be the next number, which is 749. Does that make sense, Sydney? Okay. So I'm going to clear this, clear all drawings, and let's go down. Where are we? So C, I think he's wrong. Okay, so just to finish quickly for the day, the difference between the mean versus the median, I've already spoken about this. For symmetric distributions, the mean and median are going to be approximately equal to each other anyway. Even the last example that we did, they were pretty close to the center. If it's skewed to the right, so the tail is to the right, remember, the mean is not a resistant measure. So the mean will be pulled to the right. So the mean will be bigger than the median. And if it's skewed left, the mean will be pulled to the left, and the mean will be smaller than the median. Remember, the mean is pulled more than the median. Does that make sense? Yes? Everyone?
Yes.
Okay. The median is easily interpretable, and this is very attractive in purely descriptive settings. And the mean has the unattractive property of being heavily influenced by any outliers. So if there's no outliers and it's not skewed, that's when we would use the mean. If there are outliers or there is skewness, that's when I would use the median, because I want to resist this desire for the average or the center to be pulled. Does that make sense? Quite often in the media, you'll hear something like the average salary of, you know, Americans, or the average this, or the average that. And just be aware, when they say average, they do not always mean the mean. Sometimes they mean the median, and you just got to know on a case-by-case basis which one they're talking about. Or, even better, look at the data and decide for yourself. Okay? So that was slide 12, and we're going to try to remember where we stopped, or at least I will, but I have a whole class of people who are be more than happy to point out where I'm wrong, or, you know, let me know where we left off. And we will stop here for the day. We did not finish chapter 2, obviously. We barely got started, but we did finish chapter 1, and I will have the homework up as soon as I can, and I will email the class and let you guys know that the homework is up so that you can get started and you'll have a week to do it. Okay? I'm going to stop sharing and ask for any final questions before we call it a night. Are there any questions?
Wait, so you said as soon as you're able to release the homework, we have a week from then to finish it? Or?
Yes,
okay.
Yes, it's not fair. If I take 6 more days to do it and say, okay, it's due tomorrow, that's not really fair. So as soon as it's up, I will email you, and from that moment, you will have 7 days to do it. Don't take 7 days. Take 7 minutes, right? Try to get it over with quickly, but you'll have the time to do it just in case you're on a time crunch, or one of those things. Sound good, guys? Okay, everyone, have a wonderful night, and I will see you all on Tuesday, hopefully. If you have any questions for me, just stick around. I'll stay in the chat for a little bit.
Thank you.
You're welcome.
Thank you, Professor.
You're welcome, guys.
Thank you.
You're welcome.
Hey, Professor. I came in a bit late, 20 minutes late, and I was wondering if you got me down as attended. Yeah.
I will fix it, and if I can't find it, I'm gonna try to do it. Let me do it now, Weston, before I forget.
All right.
I'm gonna forget. I came late, Jose. Okay, so hold on. This is map 140.
Well,
1 second. Let me do one thing at a time, please. Hold on.
We're literally at a picture of a Gucci box.
Hold on, guys.
That's
So Weston, you were
There's like pictures of these
late.
men against suits with
Here
cigars.
you are. Okay, and Jose Lopez as well.
yes, that's fake.
You think?
Okay.
Definitely.
I'll show you when I find one.
And Tanya, stick around for a minute. Thank you. And anyone else?
I have a question. My bad.
Yes, go ahead.
For the files and the grades, the attendance, I didn't get, well, the first class you like gave us 100% on the Canvas page, but is that going to keep on happening? Because I didn't get a notification for this class that I received
I don't
credit.
know how Canvas works. It might only give you a notification after I close it down. I don't know.
Oh, okay.
Just try to, if I make a mistake, just try to keep track of whether it goes up or down.
Can you? I'm not sure if you got me down or not. I had to type it in the chat because my internet was my internet was messed
No,
up.
I have you. I have you down. I have you down.
Okay, perfect. Thank you, Professor. Have a good night.
You're welcome. I'll see you Tuesday.
Okay, thank you. Take it.
Okay.
Question: is the homework on Canvas?
yeah, I came in a bit.
The homework will be up as soon as I can figure out how to get it up, and then I will email the class and let everyone know.
Okay. Okay. Thank you.
You're welcome. It's Heidi. 1 second. I did tell you that I told you specifically to say after class, Heidi.
Yeah, because I would be joining the classroom.
I'm sorry. Say it again.
I would be joining the classroom. I was trying to join in the classroom.
Oh, I emailed you. You mean? What? Remind me. I'm sorry. I have something going. I don't remember. Can you let me know what it was about?
I'm just trying to enroll into the classroom.
Oh, okay. So you haven't enrolled yet.
Yeah.
Okay. So what I'm going to do then is what I want you to do is I want you to private message me your ID code, your CSUN ID, so that nobody else sees it. And what I will do is I will then pass along your request to the math department. This is 140B. And Emilio, you came in a little late, so I will fix that as well. You are now fixed, okay? Taken care of. Okay, and I will send an email out. Okay, got it. You're good to go. Thank you very much. Okay, hopefully you're welcome.
Got it. Thank you.
You're welcome. Have a good night. Tanya, what's up? Are you also trying to add?
Yeah.
What's up?
Well, you told me to talk to you after class.
Did I say what it was about?
No, you just said to talk to you.
Are you already enrolled in the class?
Yeah, it says it on the portal.
Oh yeah, it's not on portal yet, but could you enroll today, correct?
Yeah.
Okay,
It
well
is on portal.
I'm sorry?
It is on portal.
Oh, it is on portal. Oh,
Yeah.
so you're good to go,
That's it?
right? Yeah, I guess I don't need anything from you. I apologize for asking you to stay. You're good to go.
Also, is there like a book for this class that I need?
There is an ebook that's going to come along with the homework website as soon as I figure out how to get it active.
Okay.
Okay?
Okay, thank you.
You're welcome. All right.
Hey, Professor Berkowitz.
Yeah.
So I was the one that showed up 20 minutes late. We already spoke about that.
Yes.
So when you were describing the graphs with the stems and the leaves, I swear I was looking at it and there was nothing but elevator music going through my head. I did not know what I was looking at. So I'm usually good with math. Usually good with math, and for some reason it just completely confused me. So what were the name of those again? So maybe I can look on YouTube and get...
They're called stem and leaf plots. And I'm sure if you do a YouTube search, you will find 1,000 people out there who explain them.
Thank you. It must have been something simple because everyone else seemed to get it, and I just...
Yeah. No, listen,
I was stumped.
Listen, everything is simple when you know how to do it, and everything is hard when you don't. Okay, so if you don't understand something because you missed it, then anything's going to look impossible. It doesn't mean it's hard. It just means you don't know it. You watch a video or two, it'll become very clear.
Fantastic.
And if not, let me know. If not, let me know.
Okay. So let me double check because I haven't gotten an email back from you, but I have eventually found solutions to all my questions. Just double checking that you are david.berkowitz@csun.edu, right?
Yes, but my CSUN email, I have to forward it to my regular email because I haven't internalized checking it daily. I just got a new email and I have to do a different route to get there. And,
got it. Is there a better email for me to reach you, or should I just wait?
You know what? I'll give my class my personal email because it's what I check every morning. It's just the easiest thing. So I will give that to the class. It's a lot easier than my CSUN email.
Great.
So I'll do that. You'll have it shortly. Sound
okay.
Good?
Thank you so much, Professor. Have a great night.
You too. Take care. Bye.